just a few words about me. I'm Paolo. I'm an Android developer and Blinkist. I'm based in Berlin, but I'm from Italy. And as hobbies, I'm an open source contributor, and I'd also like to play jazz piano. Today, we will talk about Bluetooth. You may ask why Bluetooth? Well, because in my previous company, I worked with Bluetooth devices for almost 6 years. So I said, why not make a summary of what I learned in those years? And so I can help you out, maybe picking the right library, picking the right tools. And also because I don't know why Bluetooth seems a little bit complicated and a complicated topic on Android, and there is not much documentation available out there. So let's start. First of all, what is Bluetooth? So just a few words from the basics. It's a short-range wireless technology that operates on the 2.4 gigahertz. And you may be familiar with the 2.4 gigahertz because it's the same range used also by Wi-Fi. And I can remember on my first phone, when I was connected to my Bluetooth headset, it was a Xiaomi phone. Actually, the Wi-Fi in the 2.4 gigahertz Wi-Fi disconnected from my phone. So I said, what's happening there? And then I found out that actually the frequencies are the same. So if the two antennas are like together, like too near each other, they can interfere. But the problem, of course, with newer phone, it's another problem. Some trivia about Bluetooth. It takes its name from King Harald Bluetooth because he tried to unify the reigns of Denmark. Because those three companies, Intel, Ericsson, and Nokia, tried to unify and standardize the short-range communication protocols in the world of devices, and they succeeded because we had the first draft of Bluetooth published in 1999, then the first phone released, and so on. We had some more releases of Bluetooth with more features. But today we're gonna focus on Bluetooth 4, releases in 2013, which is called the Bluetooth Low Energy. In fact, we define Bluetooth Low Energy and all those other protocols, high speed, enhanced data range, as Bluetooth Classic. So we have Bluetooth Low Energy and Bluetooth Classic. So first, let's see a comparison between the two. So Bluetooth Classic is not low energy, so it's battery intensive, and it's usually long range and used for application that requires a throughput of data which is not indifferent. For example, could be streaming of music, streaming of video, and so on. And is mostly oriented to connection, so one-to-one connections. Bluetooth Low Energy instead is low power, so it's suitable for devices that have small batteries, and it's mid-range, and also it's used in many applications, most of them sensors, a lot in IoT, and Bluetooth beacons. And the topology of Bluetooth networks can be, of Bluetooth Low Energy networks can be of those three types. They can be one-to-one, one-to-many, and many-to-many with Bluetooth meshes, but meshes are a complicated topic, so today we're gonna focus only on one-to-one and one-to-many. So what are the applications of one-to-one? Sensors. They can be anything like temperature sensor, cadence sensor for your bike, healthcare sensors, and so on. And the maximum number of connections that you can form, for example, your phone can form with other devices, usually 20. There is not a right number because it depends on the implementation, but it's around 20. With one-to-many, one-to-many, yes, you're not forming a connection, so you're not limited in connection, but I mean, you're using the air to transmit information, and the air is limited, so you're just limited by interference. Let's start seeing more about one-to-one. We're going to start with the generic attribute profile. So the generic attribute profile is a framework that defines how data is exchanged between two or more Bluetooth Low Energy devices. And this is called GATT, Generic Attribute Profile. The architecture is simple. It's a server-client architecture. We have a server that holds the data, and the client wants to access the data, read the data, or write the data. So in our example, the server could be a temperature sensor, and the client can be your phone. Those are the building blocks of the generic attribute profiles. We have attributes, services, characteristics, and descriptors. Actually, all of that are attributes. In fact, this is called the attribute table. And so we have the service, and those are nested into each other. So we have the services that basically are the logical components that our server exposes. For example, for a temperature sensor, we may have, for example, two services, one related to temperature and the other one related to, for example, the battery, because maybe you want to know also the battery of the device you're connecting to. And then we have the characteristics that are the actual data that you want to access to. And the characteristics can be temperature and humidity, so a service can have more characteristics. And for the battery, of course, is the battery value. And then, as an optional attribute, we can have descriptors, which are just metadata associated with a characteristic. So they can be the unit of measurement of the characteristic, for example, or more information that you want to provide. And this scheme here, so the collection of services, is called the profile. So right now we are defined one profile that for us is the temperature profile, which is composed by temperature service and battery service. But if you go to the web, and this is generic because you can, with those generic components, you can build what you want. But if you go to the website of Bluetooth, you can find that there are a lot of profiles out there. There are like headset profilers, heart rate profiles, heart thermometer profiles. So if you want your app to support a specific sensor, you can just go to the site, the website of Bluetooth, and know about that profile that you want to support and integrate with them. So if we click on heart rate profile, you can download the datasheet and you can see all the characteristics available. And if you actually connect to a device which supports the heart rate profile, you can also see the data. So you can see there the value that with the BPMs for the heart rate, and you can also see that other characteristic, which is body sensor location, and the value is finger because the sensor is placed on the finger. You may also notice all those other words which are called properties, and the properties tell you how you can interact with the characteristics. You can read a characteristic, you can write with an acknowledgement or not, and may seem crazy to write without acknowledgements, but this can improve the battery of your device if you don't require a response. And you can also be notified when a value changes. Imagine that you are connected to the sensor on your bike. You want to be notified of the real-time velocity of speed of the bike, for example. And that was one-to-many. One-to-one, sorry. What about one-to-many? The main application for one-to-many connections are beacons to enable, for example, proximity services in your apps. So at my company, I did indoor localization, which is basically sensing the beacons in the environment and knowing basically the signal strength at the receiver, which is called RSSI, Received Signal Strength Indication. And with this information, you can know the identifier of the beacon, you can know the estimation of the distance, you can know basically when you are in the environment, for example. But you can also have simple use cases, just detect a beacon and unlock something, for example. So this is not oriented to a connection with the device, it's just advertising and scanning. But let's see now how BLE interacts with Android. Let's start from the beginning. So let's start with permissions. As you may know, permissions on Android sometimes are complicated because there is a lot of legacy in older version of Android. So there were those two permissions which are now defined only until SDK 13. And now you have more granular permission depending on what do you want to do with Bluetooth. Do you want to scan, do you want to advertise, or do you want to connect to a device? So you can ask the appropriate permission. But as I said before, if you just scan for Bluetooth devices, that information can spoil the actual location of the user. So Android forces you, if you declare the scan permission, to also declare the location permission on the location in background permission. If you just want to scan for devices and you're not using them for localizing the user, you can explicitly say that enable that flag, which is Bluetooth scan, but never for location. And this is basically the permission request that will be shown to the user. So this was permissions. Then let's see scanning. You can actually use the Bluetooth scanner, like get the Bluetooth adapter and then get the scanner. And you may notice that, oh, nice, okay. Nice. So you may notice that the scanner is not Bluetooth scanner, but it's a Bluetooth low energy scanner. So we have totally two different scanners between Bluetooth Classic and Bluetooth low energy. And an example method for scanning for device can be this one. So you just start the scan, providing a callback, delay a little bit, then stop the scan, and then the callback will provide the actually the device that their phone found. If we go to the declaration of start scan, you can see in the documentation that it accepts more values, not just as callback. You may provide filters, settings, and then the callback. So basically, some settings that you may want to modify are, for example, the scan mode. And with the scan mode, you can tell the phone how much battery do you want to use and how much fast do you want to retrieve the results of the scan. So low latency has a lot of power impact, but you can also use the modality like opportunistic that will only scan if other apps are scanning. And then there are other power enhancement that you can use, like having delays when the results are delivered to you, so you can just batch some more results and gain more battery. Then you can also specify filters, and those are very important because, as I said before, there are some known services. So you can just use the UID of a known service, for example, the heart rate service, and support in your app only the heart rate in the environment near you. So you can use a UID, you can use the specific Bluetooth MAC address of the device, or you can use the device name, but device names can collide, can be the same between devices. If you look at the Android source code, actually, if the screen is off, so if you're doing background scanning, you're actually forced to provide a filter. So you cannot just scan for everything, you have to provide a filter. Instead, the scan will not work. So let's rework our code and under the filters and the settings. The callback instead looks like this one. It's very simple. You have the on-scan result that is called each time that a new device is found, basically. And you also have the on-batch scan result. If you added a delay, the result will be delivered there with a list and all in batch. And then with this, you can just connect to a device. But again, if you look at the documentation, for example, the Nordic conductor documentation, Nordic semiconductors, and you look for the word bug, you will find a lot of results. For example, this one, this other one. So the behavior of this is not very consistent between all the Android versions, and that's why you probably end up using a library that covers all those use cases for you. So I can suggest those libraries from Nordic Semiconductor, which are very good, and there are a lot of good examples out there. I use this one, which is the Android Bluetooth Low Energy library, and it's also an alternative, which is the Scanner Compact library. And the aim of the Scanner Compact library is offering the same API surface, so you can just use the same API. There is no much effort to migrating from the official API to the one from Nordic. But if you need to start from scratch, you feel adventurous, you can also use the Kotlin BLE library, which is more simple to use. And as you can see, provides more idiomatic ways to access the scans. So right now we're gonna use that. It has the same exact components of the one from the Android framework. You have the filters, the settings, and the scanner. But now, when you call scan, you don't need to provide a callback, but you can just collect the scan results. So this is a flow. And you don't need also to take care of canceling the scan, because this is a suspend function, so it will know when to stop itself, thanks to the scope, basically. And if you see behind the scenes, this is just a callback flow that covers all the methods that were seen before. So that works with some little workarounds for some devices, some Android versions, and so on. What if you want to scan with the app closed, for example? Well, the same function can be provided with an intent, and you can delegate the Android system to call your app when the unmatch is found, for example. So you provide the intent, and the same story, you provide the intent to the function, and you will have the onReceive that can perform some stuff. Does it work? Not always. From our tests, it works well on Pixel devices, for example, when the battery is good. But on other devices, the results can be inconsistent. Let's say on other devices, it doesn't work at all sometimes. So I can suggest you, if you really rely on if you really want to rely on some scans, to use Work Manager or have your own foreground service for that. You can do some little tricks like scheduling periodic work. You can also schedule a scan on an event when you receive a notification when you enter in a physical area with the geofencing events if you want. And so on. So if you want to go in background and be reliable, maybe use foreground services or Work Manager. What about connecting? Again, we're using the library from Nordic Semiconductor right now. And Nordic defines an example service that you can use to just have fun with Bluetooth. And we'll use this one in this talk, which is called Blinky, because it's just a LED that blinks. And also a button. So let me zoom on that. If you go to the README, it's a service that has an UID and two characteristics, which are the LED characteristic that you can read or write, and you can know if the LED is on or is off, and the button characteristic that you have the property notify, so you can observe when the physical button on the device is pressed. So let's take all of those UIDs and let's put them in some constants. We'll assess them later. So let's assume that we got the MAC address of the device we want to connect to from the previous code. So you have scanned for the device, you have found the right one, and now you know the MAC address. You can just connect to it. After you connect to it, you make sure that you are connected, of course, you can discover all the services, the BLE services supported by the device. And then, so you're basically connected. There's not much, there is no other things to do. It's very easy to connect to a device. And again, those are coroutines. So if anything goes wrong, the coroutine will just throw an exception. So you need to catch that, and you can react in that in a Kotlin friendly way. Next, sending and receiving data. So let's start from when we left off. So discover services. If we go into the declaration of client BLE get services, we can see that he has a nice function, find service by UID. So we already know the UID, which we have defined in our constant. So we can put the UID there and find the right service. So the code will look like that. We find the service, and we also find the two characteristics we are interested on, the LED and the button. And remember that we need to read or write. I just put read because it's more or less the same, so we'll just read in this example the state of the light, and we want to be notified when the button is pressed. So the code will look like that for the LED characteristics. So LED characteristics.read. But now you would expect that this is a Boolean. Instead, this is a data byte array, because if we see the specification of the service, of the characteristic, basically the data is that 01 if on, 00 is off. So we also need to make a parser for that and all of that. This will become handy later. So after we make that parser, we can just get a Boolean result that we have parsed from the bytes. And the same we can do with the button characteristic. And actually the button, we want to be notified when the button is pressed, so this will be a flow. We can call get notification and collect actually when the value is changed. And again, I will not show you that, but we made a parser with the data got from the BLE device, and we can know as a Boolean if the button is pressed, yes or not. So you may notice that we need to create a lot of parser for that because we need to interact with a lot of raw bytes. And that's why, again, if you're using a known attribute profile, a known service, you can find online some parsers, some already defined parsers. And again, this is a library from Nordic Semiconductor. This is this BLE common library that offers all those parsers for all those devices. So you need to interact with a glucose Bluetooth device, the parsers are already there for you, and you will end up just with the data that you need. You don't need to interact with bytes. Actually, this library integrates seamlessly with the Android Nordic library. You cannot use that like so seamlessly with the Kotlin one, but you just can copy the classes and, you know, until it's supported also in Kotlin. And this is an example of the blood pressure parser. You can see that you already have some Boolean stuff that are related to the service. You don't need to interact with the raw data. Also, what about Android X Bluetooth? Because there was a new library released 1 year ago and is still in Alpha 2. I don't know about that because I never used it in production, so I just played with it. And for now, it's still in alpha, so let's hope Google will support that a little bit more. But I can point you to this great article about Android X Bluetooth that goes into really deep specific implementation of that library and tries to make like a summary of the behavior of that library. It's promising, but it's still an alpha and it's 1 year later. But yeah, so some useful tools that you can use. NRFR Connect is basically a UI interface to see the device around you. You can connect to devices, and you can also see all the services of those devices and all the characteristics of those devices, and you can actually write or be notified on some of them. So if you need to debug a Bluetooth device, you can just use this app. It's very easy. Also, there is the toolbox, always from Nordic Semiconductor, that has support for known attribute types. So you can just choose the device you want to debug on, and you can have all the data specific to that device. This is an example of the cadence, speed cadence sensor. And last, I've been using the DFU library, which is for updating the firmware of Bluetooth devices. And this is also a great library for just providing the file that you want to upload, and it will take care of flashing the firmware for you in just one function. And this was one-to-one. Let's move to one-to-many. So in one-to-many, as I said before, we don't need to form a connection. It's more simple. So you have a Bluetooth beacon. You just want to catch the packet advertised by this Bluetooth beacon. There are some specifications, again, some standards, a lot of standards. The most common ones are iBeacon and altbeacon. Yes, it's called iBeacon because it was invented by Apple. Because iBeacon actually is the most common one, our example will be supporting the iBeacon protocol. And you can see that actually you have the standard BLE advertising packet, so there is nothing special about that. The only values that you should be interested on are these three, which are UID, major, and minor. And those are the only three values that you can personalize easily with those Bluetooth beacons. So you can use those three values as a key to identify one beacon instead of another beacon. For example, a logic thing that you want to do could be in the use case of indoor localization, using the UID to identify all your beacons. So all the beacons that your app support have the same UID. Use the major to identify the floor you are in, so floor 3, floor 2, and floor 1, and use the minor to identify the specific beacon on the floor. So the final key, the final composite key of the beacon will be with the major and minor. On Android, to detect those beacons, you can either scan for devices and parse all that Bluetooth packet and get those three values, or you can use altbeacon beacon library, altbeacon Android beacon library. And it's a very convenient library, it's very easy to use. It will just take those values from the scan and expose them to you. If you need to support Kotlin multi-platform, at my previous company, we made a Kotlin multi-platform version of this library, just a wrapper that uses the same interface also for iOS. So could be handy. And it works like that. So you get the beacon manager, and you add the parser you want. I said before that there are different formats of that, and only the position of the byte different between one format and another. iBeacon is a proprietary format by Apple, so you need to just tell the library where to find those bytes in the advertising PDU. But you can just find this string of Stack Overflow, for example. So you can just say, I'm interested in the iBeacon layout, takes this layout, and it's just a magic string that you need to provide to the library, and the library will know where to get the interesting part of the advertising packet. So this is a constant for us. We just added the iBeacon layout, and now we support iBeacon. So now we can scan, and we can scan in two ways. We can either range or monitor. So ranging is basically looking for the specific beacon, so looking for the specific value of UID major and minor. And monitoring is looking for a region, so a group of beacon. For example, if we are interested only on the floor of the user, to have more battery, we can say we define some groups with all the floors, and we can start monitoring. So we will be notified only when we enter a floor and we exit a floor. But if we need to do indoor localization, so we need to know the exact position of the user, we need all those beacons, so we can use the ranging. And ranging is more battery intensive. And ranging will provide you the UID, minor, major, and the estimate of the strength of the signal at the receiver. So in this case, we just want to range, for example, and you can see, add a new range notifier. We specify the region that in this case is all. This is the name of the region. You put the UID major and minor there. I put null because I'm interested in every beacon that it's in the environment. But you can also put the UID of your beacon there to support only your beacons in case there are other beacons. And you can start ranging. And the same is for monitoring, but for monitoring, you actually need to define a region or more region based on what you want to do. For example, this is the floor. We have our D, and we just put that the major should be 2 because of our convention, and the minor will be null because we are interested in all minors. So in this case, we are all selecting all the beacons on the second floor. And the result will be that callback. I entered the second floor, I've exited the second floor. Again, if you want to do it in background, as Beacon supports you, it has a foreground service that runs for you, but if you want to handle your logic, you can just do it yourself. So use altbeacon in the normal mode, but in your foreground service and in your work manager, for example. Some use cases of that, you can use beacons in museum, for example, to enable proximity services like showing information about the thing you're looking at, because you can just sense the beacon and show information on the phone. You can use it for smart cities to make like intelligent stops. And again, as I said, you can use it for positioning because, of course, there is a direct correlation between the signal strength and the distance you have from the beacon. But it's not that easy, because the problem is that the signal from the beacon reflects on surfaces around you. So the beacon that you receive as the most powerful one is not, it could not be the one that is actually near you, because it can reflect on metal, for example, it can reflect on the wall, and the signal can be intensified or can be lower than expected. So even the humans, even if you are holding your phone, the beacon behind you will be much weak than the beacon that is in front of you, for example. So you need to accommodate for that. And there are also filters that you can use to compensate all those errors. For example, you might need to do fingerprinting on the environment or apply other strategies like machine learning. And actually, that depends also on the phone antenna, because different phones are different antenna with different sensibilities. And in that case, actually, you can help defining a common database of phone antennas measurement, because in altbeacon, there is already an estimate of the distance in meters. So in the range notifier callback, you can access this property distance, and it's actually an estimate. But you can use your phone to actually calculate some constants that are defined in the wiki of AltBeacon, and you can add those constants in the GitHub repo of the library. So more people contribute in this project, more people make some help scans beacon with their own phones. More phones are supported by this, and more precise will be the relevation by the library. Again, useful tools. AltBeacon offers also an app that you can use to basically scan for beacons and just estimate the distance between them. So this is another tool that you can use to debug first and then develop a use case. So that was all. Do you have any questions? Thank you. Okay, I think there are no questions. So there is a question. Go, Ivan.
What kind of device you will advise to buy to start playing around?
Okay, if you want.
I have a lot of those, thermometers and things, but
You mean sensors or phones?
yeah,
Because
sensors.
for phones, the easy way is pixels because they usually work in all use cases. But yeah, it really depends. I've worked with beacons. It depends on the. They're more or less the same, and they can differ only by the size of the battery. So you can put, if you put some beacons in some difficult venues, you want a big battery, so you can just change them in 5 years, for example. So you don't need to deploy a lot of beacons in the environment. But if it's just for playing around, they can be like €1 beacons with a small battery like the one in your clock that works anyway. As for smart sensors, I've used cadence sensors in the bikes, and they're quite cheap also. You can just put them in the wheel of the bike, and they will tell you only the revolution of the wheel. And based on the revolution and based on the time, you can estimate the speed, and so you can play with that. But there are a lot of smart thermometers, so you can build up based on the temperature inside your home, humidity, and they are very easy to access with those libraries if they follow the standard Bluetooth specification. So make sure that they follow that. Yeah. Yes?
Yesterday, Droidcon talked about a cable library. There's another library we have in deals with the ideal secrecies of different hardware.
Okay, to be honest, I've not used cable because I had this big app that already had that library at the early time, so I did not migrate to anything else. I just migrated to the Kotlin Nordic Semiconductor Library, and I used more or less Nordic Semiconductor Library because they are the one that define the Bluetooth Low Energy standard. So maybe, it's more, I don't know, but yeah, also other libraries are fine, but I have no experience with it. Sorry. Right, okay, you can, yeah, yeah. Yeah, so it depends. It's the question is the companion mode. It depends on the device. Could be, and use that mostly because you can avoid some optimization, battery optimization by the operative system, and you can say I need to connect to this device, for example, a clock, and the phone will just exclude your services from the battery optimization, and your service will be alive if you need to maintain a steady connection of all the day. So yeah, you can look into that for wearable devices, for example, that you need to be connected like all the time.